In this video, we're going to take a detailed look at the central and largest structure within the solar system, which is, of course, the sun. Now, in the ecology unit, we learned that the sun is the energy source for all living things on Earth, and therefore, without the sun, no life on Earth or even anywhere in the solar system could exist. Now, before we look at the different parts and functions of the different structures in the sun, we should take a second to appreciate the sheer scale of the sun compared to the rest of the solar system. If the mass of every object in the solar system were added up, the sun would account for approximately 99.86% of all mass of every object within the solar system. Put in simple terms, the sun is very, 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 very large, even compared to Jupiter, the largest of the planets. Now, if we look on the inside of the sun, similar to the inside of a planet, we find a structure in the center called a core. And in the same way that all energy on Earth that is produced by the Earth and not absorbed from the sun originates from Earth's core, the same is true with the sun as well. This is the source of all of the energy that is produced by the sun and that is then released into space. Now, the source of this energy comes from not a chemical reaction, but a nuclear reaction, that being a reaction that takes place between the nuclei, the central particle with the protons and neutrons of elements. And this reaction is what we call nuclear fusion. So the word fusion is a noun, which is derived from the verb to fuse, which means to join together. So what a nuclear fusion reaction does is it takes smaller elements on the periodic table, and if you remember from the chemistry unit, the smallest element on the periodic table is hydrogen, which exists in the form of hydrogen gas. And when nuclear fusion happens, it joins the nuclei of multiple hydrogen atoms together in order to make larger elements. And the first element that is formed when two hydrogen atoms fuse together is, of course, element number 2, helium. And when this nuclear fusion reaction takes place, the nuclei release a phenomenal, nearly unquantifiable amount of energy that radiates out from the core and eventually is released into space. And some of that energy eventually makes it to Earth, powering photosynthesis and allowing life to exist. Now, if we follow that energy as it is released from the core out to the surface of the sun, we will eventually hit the sun's atmosphere, where, just like the atmosphere of a planet, that's simply the outer layer of the sun that is composed of gas, again, mostly hydrogen and helium gas. Now, the atmosphere of the sun can be divided into two parts. The layer that is closest to the surface of the sun is what we call the chromosphere, which will be looked at in more detail. But if we were to cover up the sun like the moon is doing here when it blocks the surface of the sun, we can see that only the outer layer of the sun's atmosphere is visible, and this is what we call the corona, which is a word that is derived from the Latin word for crown, because it looks like this is the crown that the sun wears on the outside. And this picture was taken during a phenomenon when Earth's moon passes in front of the sun, blocking the surface of the sun, the chromosphere, except for the corona. And this phenomenon is what we call a solar eclipse, which will be explored in more detail in a following video. Now, if we take a look at the chromosphere and look on the surface of the sun, you will be able to see dark spots on the surface of the sun that have a lower temperature than the rest of its surface, and these are what we call sunspots. Now, sunspots have very interesting implications for Earth because sunspots are the origin points of these large releases of gas and electromagnetic energy that are released from the surface of the sun, and these releases of solar gas and energy are what we call solar flares. Now, solar flares can actually get quite terrifying. We can see that there is a very, very large solar flare that has been released here, which is actually extending hundreds of thousands of kilometers away from the surface of the sun. And this large solar flare is what we call a solar prominence. And again, these are simply even larger ejections of gas than regular solar flares, which once again originate at these dark spots, sunspots, on the surface of the sun's chromosphere. Now, again, these are very important on Earth because of the energy that they release and the implications that energy has when it makes it to the surface of the Earth. So all energy that is released by the sun is what we call electromagnetic radiation. And the simplest form of electromagnetic radiation that most people are familiar with is, of course, visible light. So all colors that we see on Earth, we would only be able to see as a result of the solar radiation that is making it to Earth. But this also includes very deadly forms of radiation like ultraviolet radiation and gamma rays that are known to cause cancer. However, of interest to humans, especially for communication purposes, are microwaves and radio waves, which we use in microwave ovens and in radio signals for communication, as the name implies. Now, one of the ways, or one of the more spectacular observances that we can make of electromagnetic radiation from the sun, we can actually see in the sky right here. So what exactly is going on? So the EM radiation, EM is electromagnetic, that electromagnetic radiation that is released from the sun is going to travel through space, and this is a phenomenon that we call solar wind. It's not literally wind because when it travels through space, there is no atmosphere in space. We simply use it the term solar wind because solar wind is actually able to blow substances through the vacuum of space. And eventually, when solar wind makes it to Earth's magnetic field, it's going to cause a number of visible effects that we can see on the surface of the Earth as the solar wind radiation interacts with the Earth's atmosphere. So this interaction between the radiation of the sun and Earth's magnetic field produces these very characteristic colorful displays in the Earth's atmosphere, usually around the poles. And these are, of course, what we call auroras. So the technical term for the auroras in the northern hemisphere are what we call aurora borealis, or the more colloquial term for them is the northern lights. However, we in Canada are not quite familiar with what happens at the South Pole, given that we live closer to the North Pole, but auroras also occur around the southern hemisphere as well, in which case they would be called aurora australis, or more colloquially, the southern lights. And if you haven't seen the auroras firsthand, it is a truly magical experience. Although magical, not quite correct, because there is a very clear scientific explanation behind how the auroras occur. This concludes our video about the sun and the energy that the sun produces. In our final video about the solar system, we are going to be exploring the celestial bodies that are neither planets nor a star that make up the remainder of the solar system.